Hello, sorry I'm late. Stuck in my way. We were eating lunch. Um, yeah. Welcome out to the 2 stream. It's Tuesday. Probably if you're here, you're watching on YouTube. Well, it's on YouTube, but I mean the VOD, not the live one. I could watch, and I gotta find the chat. Where are you, video? We're live, I think. Oh. Nope. What is going on? There we go. Found it. Hello. Hopefully you're doing well. We're gonna get weird audio issues there. All right. Hello. Yeah, I hope you're doing well. As I said again, chat's there. Today we're gonna be talking about 8.5. We're gonna do some recursive rules. This section, hopefully, it's basically what we've been doing, but the main thing to get is the notation. So hopefully it's not too difficult. Hopefully. Just making sure I have all my windows on my computer set up correctly. Yep, looks like it. Yeah. So welcome to day whatever, I'm actually counting, of quarantine. And we'll probably have a on the stream later. So I'm just writing a note for myself. You want this too? So we're going to start with review. Oh, come on, camera. We're going to start with review, and then we will go back and we'll go back and do review first, and then we will do some new stuff. But we're going to wait a minute for some more people to show up. I want to make sure that I have the problems. For the practice that I wanted us to do 7 through 14. I am a bit concerned how many we have showing up. Okay, so we've got a few people. I wanted to remind you, or to be clear about something. I'm new at this, right? And it's obvious my stream quality is like super high. Lots of editing, technical tricks, and all that kind of stuff. But one of the things that I've noticed is really helpful is just to not talk to a blank wall. So it's not like I put a... See? Yeah, random buttons get pressed and things change. It's not like I put a picture up on my wall so I have like a random fake human to look at. No, I mean like when you guys talk in the chat and type, it's really helpful. So just to pressure you a little bit. It just makes me feel like I have someone I'm talking to and not just talking to an empty void. And empty voids are not the most fun in the world, right? They're soulless death traps. So we have Sam. We have a few things to do. I want to remind you that you can contact me through Remind, which is probably the best way. If you have a message, if you have a question or something you want to tell me, Remind is the best way to get in touch with me. Email, I will check eventually. Sometimes I'm bad at reading those and then not replying to them, so Remind is often the best thing. And if you send me work, I'm not going to be like, oh, I got it. I'm going to just be like, oh, okay, I got it, and I'm not going to respond. I'll put it in later. I haven't gotten any like tests. You're finally time. Yeah, it's true. I was tardy. I was a little late. I haven't got any like makeup tests. So if you have questions on how to do that, message me. do the study guide first, and then the test in Khan Academy, and then like record your results so that you can send it to me, because I'm not sure I can see your scores in Khan Academy unless I assign it, and I'm not going to assign it. You have to figure it out. I'm not going to assign which test it is. You have to figure out which test it is. That's what we have to figure out. I will help you if you need help. What was I going to talk about? Oh, schedule this week. We have a stream right now. We'll have a stream on Thursday again at 2. And I might. What? Excuse me. I think I'm okay with that schedule. Part of me is. I might change that. We'll see. And then Friday, we're going to do a Zoom meeting. Thanks. Yeah. We'll do a Zoom meeting. So Friday at the same time. So Friday at 2. I know some people said they couldn't make it. That's okay. You just have to send me a message if you have questions. Hey, Peppers. What's wrong with you? You want to see the people? Actually, you won't be able to see anybody, but they want to see you, I think. Yeah, come here. Come on. You're all right. No, I got you. Hey, look at you. Oh, you're chewing the finger. Okay, so Sam, the best way to raise your grade, it depends on what your grade is and why it is that thing. So if you're missing school classwork or like homework, you should go on Atlas and figure out what those assignments are. Look at that email I sent you. You're chewing on my finger. I don't like it. I don't like that. You went down. Okay. Here, you can play with this. So if you look at your grade in Atlas and you're missing like a lot of classwork, or like participation type things, those are in the Dropbox, so you can find them and you can do them. You download them, show your work, and then send them to me. Same with homework. You can go in Atlas; it'll tell you the page number in the textbook and the problems, and you can do those and send them to me. Reminder or email, either way. The other thing is if your tests and quizzes are low, which who knows, I'm not, I don't know, specific, but if your tests and quizzes are low, the best way to do that, there's only one way to do that, is to write a study guide for each of those. So same quizzes as well. Write a study guide for the quiz. The quiz is like this part of the section of the book, or like this part of the chapter, this tiny piece, right? And remember, the quizzes we took in class were not very long. They were like 6 questions. So you only need to do like 6 questions for a study guide. So you do a study guide for whatever that assessment covered. So if it's a test on Chapter 6, it'd be all the stuff in Chapter 6 on the test. So you'd write a study guide for all the stuff in Chapter 6. Excuse me. If it was a quiz on like 6.2, that probably covers 6.1 and 6.2. So it'd be stuff that short quiz on those things. So you write a study guide, and then once your study guide is done, you would. I think she went under the bed. Oh, okay. After you've written a study guide, you're going to go on Khan Academy, and you're going to take the closest assessment on Khan Academy. So if it was like logarithms for that chapter, you'd go find the logarithm section on Khan Academy in Algebra 2, and you'd take the test. They have tests. And then you'd send me both of those things. And I'll be like, this study guide really only covered like half of it. You need to do more. You didn't really do well on the Khan Academy test. You should probably take it again. Stuff like that. Okay? So that's how you would make those up. And there's quizzes and tests on Khan Academy. So there are ways to do both of those things. Okay? And I'll probably have to give that same spiel again later because we only got 5 here. Okay, so we are going to start by doing, and this is why I have this. We're going to start by reviewing the problems from the last section that we did. So that was infinite series, sums of infinite series, page 439 in the book. Hey, Misha. You need to either go hang out with Summer or go to bed. I can't pay attention to you right now. 7 through 14. Yeah, it'll be about with what I just said. Yeah. All right, and then the Zoom on Friday. You'll get an email invite in your Fresno Unified email, so don't check your Wee Tigers email. I know that's been an issue. People don't know which email is which. So Fresno Unified, there'll be a password in there that you need to use. Okay, it'll be like a number. You have to type it in. So that's so we don't get like, if people are posting weird stuff in our Zoom or showing weird stuff, it'll be you guys, and I'll know how to track you down. Okay, instead of like random people from Canada or New York or something. Okay? So, before we get into new math, we'll probably end around 2:45 today. We're not going to go super long. Today's lesson is going to be the last part of Chapter 8. On Thursday, we are going to play a game. Basically, the whole lesson is going to be like, can you solve this puzzle? This is a game. And it'll have to do with, we'll do two things, Fibonacci sequence and Hanabi's tower. So that will be on Thursday. And today we're going to talk about recursion, which means doing the same thing over and over, finding the thing before to kind of find the sequences. Because that's a pretty typical thing. Like, oh, there's a pattern. I know what the pattern is. Can I find a previous result? That's our goal. Okay, so before we get to that, we're going to do some review. So the review looks like that's the button on it. Just like this. It was 7 through 14. Okay, and so then we had a formula, which that button. Yeah, our formula was the sum of our infinite series is our starting value, sum of infinity really, divided by 1 minus the ratio. Yeah, happy birthday. Poor puppy. Okay, so that was our formula for infinite series. Okay, and so we need to find some things. You use the summation notation. Find some things. So here, number 7 says we're going from 1 to infinity. We're starting at 8. We're dividing by 5 every time. Okay, so our starting value, so this is number 7. Starting value was 8. We're going to divide that by 1 minus our ratio that we're multiplying dividing by. Samuel wants a fry. I would give Samuel a fry, but I don't know how to get it to him through the computer like this, so I'm just going to eat them and make him feel bad. Not good. Okay, so here, number 7, we have 8 over 1 minus a fifth. This is a fifth, so it will converge. Okay, because remember, r has to be smaller than 1. Hey, stop chewing on that. Yeah. Okay, and then we put this in a calculator. You get 8 over 4 fifths, which is the same as 40 over 4, which is 10. I think my dog is teething. She's chewing on everything. I don't have any stamps for mail, guys. Remember when we divide by a fraction here, we flip the fraction and then simplify. Okay, so that was number 7. Number 8, it doesn't exist because the ratio is bigger than this 3 over 2. It's bigger than 1, so it doesn't convert. Just like this 5/3 doesn't convert. For these, we just need to know what's happening. What are we multiplying by to get 2 to 6 over 4? Sorry, excuse me. Well, I think for 11, I'm not going to do the other ones. The other ones you just plug it in. It's really easy. For 11, we're going 2 plus 6 over 4 plus 18 over 16. 8. So this is our ratio, and it goes on. Well, we only need a couple. What can I multiply 2 by to get 6 over 4? So 2 times 3 over 4 is 6 over 4. And if I multiply that by 3 over 4, I'm going to get 18 over 16. 4 times 4 is 16. 6 times 3 is 18. Okay? So this is R. This is A1. So then we have our formula, right? Yeah, matter. Okay, so we plug those things in. Up here, our sum is going to be 2 over 1 minus 2 over 4. 2 over quarter is 8. There are 8 quarters in 2. Okay, so if we add up all those things to infinity, we add up every single next number, we're going to get 8. Yeah, we'll do number 12. Okay. So with these, we just need to find out what's the next number, or what's the ratio in the sequence. 12, we're going -5, -2, minus 4 over 5, minus 8 over 25. Okay, what are we multiplying 5 by to get to 2? This is confusing maybe at first, but the key here is to go from the 2 to the 4 fifths. So 2 times 2 gives us that 4 on top, but then we're going to have to divide it by 5 to get the 4 on top. And yeah, it's negative. And then if I multiply by this by 2 fifths, I'm going to get 8 over 25. So our ratio is 2 fifths, and a sub 1 is -5. So our sum is going to be -5 over 1 minus 2 over 5, which is -5 over 3 over 5, which is 25 over 3, and it's negative. Okay. Now this is using calculus a lot, so maybe we're not going to get to calculus, but you should be able to add numbers together and then use this formula to kind of find the sum. Okay? I think that's all of those I'm going to do. The rest of them are just multiply by the thing. Multiply by the thing. For number 14, don't get confused. Number 14. We're going from 1/2 to 5/3. It's going to be negative because it's switching signs. 50 over 9. Usually it's useful to look at this number and not this number. Right? Because when we go from 1 to 5, we're not multiplying by 5. Because we're multiplying by 10. We're going from 5 to 50 here, we're multiplying by 10. The reason it looks like a 5 is because we divided that 10 by 2 and give us a 5. So the ratio for number 14 is 10 over 3. And it's negative, sorry. Okay? So that's the review. Those are the practice problems I gave you. The thing that we're going to do today is we're going to talk about recursion. And recursion is just finding the previous thing. Can you find previous thing? Okay? So if we go back to that screen, so this is the student journal pages. They're in the Dropbox. If you don't remember where the Dropbox is, you should have an email that you could find again, unless you deleted it. An email. The Dropbox. The link. Okay. So this is going to kind of combine the two things we've done so far with explicit rules being here's the equation to find the number, also common difference for arithmetic, and ratio for geometric sequence. That's kind of this. Support concept is not something new, but this notation is different than what we were doing before, because this is recursive notation. Okay, our recursive rule takes the previous value, so it has n minus 1, and then we add the difference to it, and we get our new number. This is not crazy complicated stuff here. We're just going to take our previous value. The hard part here is understanding what a sub n minus 1 means. Okay, so I'm going to write a sequence here, and then we're going to talk about how to find the next number from a number. All right, so you're missing this. Crazy, right? We're adding 1 every time. Okay, so this is a ridiculous sequence. So if I wanted to find a sub 100, it's going to be 100, right? This is a sub 1. This is a sub 2. A3, A4, A5, A6. Remember, this is just the position it is in the sequence. This time, though, the sequence is the position. The first number is first. The first number is 1. The second number in the sequence is 2. The third number in the sequence is 4. So the position matches with the value. Doesn't always happen. And rarely does that happen. Okay, so these are going to be the same. A100, the 100th number is going to be 100. Crazy. How do I find that number using the previous number? This is what recursion is. We're going to take the previous number, A100 minus 1, the previous one, the 99th number, and we're going to add the difference to it, the common difference. So A99 is 99. And we're going to add 1 to 99 to get to 100. Do it this way. So to go from A99, the 99th number, to get to the 100th number, we're just going to add 1. And so to do that, we're going to take, 99 plus 1, and give us 100. Now this is an easy sequence, but the concept is the same for all arithmetic. You take the previous number, you add something to it, and you get the new number. Okay? So we can change our sequence, and we can get more complicated recursions. What if my first number was like, I don't know, 7? Well, we're going to add 4. 27. So our first number is 7. And so our recursion rule is going to be whatever number we want, you take the previous number, a minus 1, that's the previous one, and you add 4. So if you wanted a 114, you would just find a 113 and add 4 to it, and that would give you your new number. Now, I don't know what this is. We could find it. We have an equation. We could find it. But to find this one, you just take the previous one. So that's what recursion is. Find the previous thing, add to it. Now that's for arithmetic, right? Because we're adding. That's arithmetic. If we wanted geometric where we multiply, excuse me. We would multiply. So our geometric recursive sequence is going to be this thing. Our number is going to be the value of our ratio times the previous number. Whatever the previous number is, multiplied by whatever our ratio is going to give us our actual value. So if we take, let's say this sequence, so this is our rule, we're finding the recursive sequence. I don't know who JK is, but that's Sam, I think. JK is either. Ooh, whoops. Let's take this sequence. So our first value is 2, our second value is 4, third value is 8, fourth value is Misha, hey. No, I just don't want her to scratch up that board. We're doubling every time here? Sorry. She's fine. We're multiplying by 2, right? So our ratio is going to be 2. If I wanted to find any number, I would take the previous number and multiply by 2. Oh, I will. Thank you. Anyway, so you take the previous number and multiply by 2. Okay? So if we wanted to find the 13th value, we would just multiply the 12th value by 2. Whatever number this is, multiply by 2 and you get to this one. If you want to find A5, A5 is going to be 2 times the 4th number in the sequence. So you take 16 and you multiply by 2, and that would give you 32. You find A6 by multiplying A5 by 2, and that gives you 64. This multiply by 2 sequence is really important for computer memory. Really important. Everything's binary, so everything comes in bits of 2. It's always factor 2. Okay, so that's basically recursion. We have this weird n-1 thing, which just tells us that's the previous number. And then this is the value that we're looking for. If we know this one, we can find this one. Okay. I want to double check something quick. Okay. Okay, so here is our textbook example. I'm on page 442 in chapter 8. Okay. So write the first 6 terms of each sequence, and we have a recursive rule, and we have a starting value. Starting value. So our so I'll write that on the whiteboard. Yes, so a sub 0 is 1, and our rule is our new value is going to be our previous value plus 4. We're starting at 1. So to find A1, A0 is starting, A1 is our first term. We would do A sub 0, right? 1 minus 1 is 0. That's this thing, plus 4, which is the same as 1 plus 4. 5. A2, the second term in our sequence, is going to be our first value, A1, plus another 4. Well, A1 was 5, so there's going to be 5 plus 4. It's not. Now, this is not a simple idea. We're just adding over and over and over. It's not complicated. It's just kind of the notations here. So then we could do all the rest of these. We could write all this out every single time, but really what we're just going to do is add 4 to this term. So it's going to be 9 plus 4, 13. 13 plus 4, 17. 17 plus 4, 21. Okay? That's for addition. We're adding every single time. For multiplication, on that same page, we have a little bit of change. We have some function notation. So f of 1 is going to be 1. Our first number, we plug in 1, we get 1. Our function is going to be 3 times f of n minus 1. Find the first 6 terms. So our first term is 1. Our second term, f of 2, plug in 2, is going to be 3 times f of 1. Right, we plug in 2 here to this end, we get 2 minus 1, we get 1. Well, I know f of 1 is 1, so I get 3. F of 3 is going to be 3 times whatever the previous thing, f of 2 was, which was 3. So 3 times 3. So that's 9. Multiply that by 3.7, 81. So recursion is just taking the previous thing and doing it over and over. Right? Doing recursion. Now, we mathematicians like to write tables to list our numbers. It's helpful for this, especially when we're writing a rule. So write a rule for the pattern, write a recursive rule. 3, 13, 23, 33, 43. What are we doing every time? Well, we're adding 10 every time. Okay, so our table will look like this. Our first term is 3. Our second term is 13. Our third term is 3. Our fourth term is 32. Our fifth term is 43. So these again. So now we have 1, 2, 3, 4, 5. This is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. And we can use these little like arrows to keep track of what we're doing. Well, here we're adding 10. We're adding 10. It's the same, so we know it's a sequence. It's arithmetic because we're adding. Okay, this is the common difference. So 10 is D. Yeah, so that would find the value, Sam. Yeah, so 10 times n plus 3 would actually yes, but it wouldn't start at 3. Because when you plug in 0, you want to plug in 1 and get 3. So you need needs to be smaller than that. Okay. But we're looking for the recursive rule. So you're thinking the rule we did before. Now I want the recursive one, which means we need to write it as a sub n, whatever value we want, is the previous value plus whatever d is. That'd give you negative 3. 10n minus 13 gives you negative 3. You can need negative 7. But we're going to use this thing. So, yep, we're going to use this thing. So our previous number plus 10 is going to give us our new number. So the recursive rule is a sub n equals a sub n minus 1 plus 10. And our first sequence, our first number is this. Here's our recursive rule. I think I'm going off my whiteboard. Check. Yeah. Very. So this is a recursive rule. Because it gives us the previous number, the n minus 1. Gives us the new number. We added 10. Okay, the rule for this sequence, the normal rule, would be a sub n is 10 n minus 7. That would be the one that's same. Okay? But this is the recursive rule. This is just the one. Okay? And if I'm going too fast, you can always watch it back. Okay? So now we want a recursive rule for this sequence. 16, 40, 100, 250, 625. Here this is geometric, by the way. Okay, so we put this in our table. 1, 2, 3, 4, 5 things. 16, 40, 100, 250, 625. What is happening to go from 16 to 40? We're multiplying by 5 over 2. 5 halves each time. So our geometric sequence is a sub n equals our ratio times our previous number. We take our previous number, multiply it by 5 halves, we get our new number. Okay. That's it. A sub 1 was 16, so we start at 16, multiply that, and that will give us our next number. Okay. Plus. I think that is all I want for us. Oh, gosh, first of all, nah, that's it. I'm good with that. That's all we're going to do for today. Okay. That's it. I'm not going to do. I don't want to do practice problems. No. If you want to do practice problems, you can go in your textbook and find them. So I'm not worried about that. On Thursday, we will do. I'll have a website for us to go to with a copy of California on it. We'll talk about that pattern. And I don't have a lily pack in my second period. Sam, we're not going to do the fridge reveal. I think that if I get a certain level of participation, I might do those things. I'm going to use them to bribe you. Okay? So, I didn't really do it today because the lesson wasn't just about them. And fewer and fewer people showing up. So, which I understand, but seems less and less valuable. I just spend my time only getting 6 people. Kelly, I don't know. Unless you go by something else. An atlas. Unless you go by something else. I don't know. I feel awful to be like, I don't remember my students, but that happens sometimes. I don't think that's the problem, though. I think one or both of us is confused. Ha! Ah, your government name. Or something like that. Yeah. That's why I don't know who you are, Jasmine. Lily, since when are you going by Lily? Now I'm definitely the one that's confused. Okay. Andrew asks, you email me on the Dropbox for homework, but can I just send pictures of homework through my email to you? Yes. I got bad news, Jasmine. You're on the internet, the government knows where you are. They don't care, though. That's the good news. Is they don't care. They really don't. But if you're on the internet, anybody can find you, basically. Might be really difficult. It might not be easy, but they can find you. It's not a thing to worry about because no one's trying to find you. But this is the reason why people like get super weird and go hide in the mountains and destroy their cell phone and don't have Facebook. I don't think it's a bad choice. It's just not a choice. I'm okay with the government knowing where I am. Anyway. Yeah, Andrew. So if you're doing homework or something, you just send me a picture. You can email it to me or send it to me online. I don't. Whatever's easier for you. I don't care. You can email it to my. It's Mr. Ethan talk about stuff like that. What was I saying? Yeah. It will be easier for me to grade if you send it to my martensturnin@gmail.com. But if you send it to my school email, if there's a unified one, that's fine. I'll get to it. It might just get lost. We're not doing it for drills today. Michelle, come here. Okay. I know you're sleepy. It's just because you're tucking, you're getting weird. But we're going to show you off. Give the people what they want. Look how sleepy she is. That's it. On Thursday. On Thursday we will. Oh my goodness. So look at her face. Oh, you're getting annoyed. On Thursday we'll have another stream at the same time. She's pretty calm. I say that and she's freaking out. But so grumpy. Thursday we'll do a stream at the same time, 2 o'clock. Friday we're going to do a Zoom call. You'll have an email in your Fresno Unified account, with the password and a link for that, and we'll do a Zoom call. I'm not worried about the cute puppy. Anyway, that's it for today. I will see you guys on Thursday. Have a good week. Stay safe. Stay home.